This talk is Andrew Decker's talk. He was my senior developer, but he recently got an offer he couldn't refuse from a startup, and he's now working his way through issue queues rather than doing really exciting stuff at UQX. But most of the code behind what I'll be talking about today is Andrew's or from other developers in our group. We are UQX, and just to put UQX in context for those that don't know, if you go to edX and click on schools and partners, here we are fairly close to the top, University of Queensland, and we've got 10 courses listed in here, 8 of which have already run, and 2 more coming out in November. We also have an active program. We've got another 4 courses that haven't been announced yet that are already under development, and back in my office I have a very long list of potential courses for the future. Along with all of these courses comes a lot of data. When we joined edX back in 2013, our first course went live in January 2014, and then it was a few weeks or a month or so after the course started, we kind of started getting these data dumps from edX that contain the research data package. And we're really keen to make use of this data, to preserve it so that we actually have a research data set that can be used in the future. Because there's a lot to learn in MOOCs. The students are kind of distanced from us. They're not like our on-campus students where you can just walk up to a student and ask them about how they're going in the course. There are a lot of disconnected students in MOOCs as well that register and never even turn up, so you have no input from them at all other than they like the course enough to click the enrolment button, but that's it. So there's a lot of sort of stuff that we're interested in trying to find out, how students are progressing, what questions they're finding difficult, how are they actually learning, and so forth. So there's a lot of potential in the data. We see it as a fantastic thing for long-term research. Once these data sets are there, they don't go away unless we lose the data in some way. So we were very interested in putting together a system to curate and maintain the data so that it was available for researchers both now and in the future, and to use it not only for research but also for our internal analytics to feed into course selection and things like that. So we built a system, and we later named it MoocCzar after the edX name for data czars that they gave all of us that were involved in this originally. So the idea of this platform, isn't actually really specific to MOOC data. The platform we've built, it could actually be used for managing any data set that you're receiving updates on a regular basis. You could use this platform as a way of managing it. It was really our first step into understanding the structure of the edX data sets and the sorts of research questions that could potentially be asked of this data. We decided very early on to make the architecture really extensible, so that it's all plugins that can be added, and so it can evolve as time goes on. The other thing I wanted it to do was to minimise having to redo work. So if we decided we want to do a particular aggregation of data for a particular study in a particular course, that would actually happen in all the courses. And so those aggregations would just be there. So if at a later point in time the researcher said, oh, maybe I'll compare this course with that course, the data's already there, it's already done, because compute cycles are really cheap, but person hours are quite expensive. So we've separated out various sections of the platform. There's an ingester that sucks in the data from the raw files into databases and does various processing tasks. We provide an API so that not only researchers using IPython or R can access the data, but you can actually build systems that access the data through the API. And we've built some systems like that ourselves, such as our dashboard, which is our kind of institutional, top level, what's going on in our courses sort of thing. I'll talk about some of the other things we've built on. This is a very general view of how the system works. We have our edX data package, which is just a stack of files, database dumps and big long lists of JSON and so forth. It goes through the ingester on a weekly basis because we refresh the data package every week, download a new one. It gets ingested back into MySQL databases and Mongo databases and various aggregated files that are used for caching some of the results. And then all of that is exposed via APIs, and then we can build stuff that uses those APIs to do things with the data, as well as use the APIs directly if you're researching. The data packages download is a fairly simple thing. We just have a shell script running on a single machine that someone triggers off each week after they've verified that edX has actually generated the data package on time, which doesn't always happen. And I have noticed it's been getting slightly later every week. It must be that the data's growing. So it used to be every Monday morning. And now it's every Tuesday morning.
John and Olga are going to duke it out later.
Now, I fully understand the challenges you must have generating these as the number of courses and partners go live. So I'm just digging a bit. So we unarchived that, and we've leveraged a national research infrastructure that the Australian government put in place a few years ago. So they've created a cloud service for researchers that has a data service and a compute platform. They're both based on OpenStack, but we don't really see too much of that ourselves. We just generate the VMs and we're given a data allocation. We've got 10 terabytes of data storage. And so all of our data is archived in the National Research Data Archive, so we don't have to worry about backups or anything like that. It's there, it's preserved forever, along with all this other research data around Australia. And then our ingester and our dashboard platforms are all hosted on the compute infrastructure, and it costs us nothing. Isn't that wonderful? It's the best bit about it. The ingester is a very modular system that understands what the files are and how they're structured, and it processes through them. It has a dependency list, so you can have various processing actions that happen after a particular file type gets ingested, such as converting IP addresses to country codes, or doing things like aggregating number of posts, or the number of sections opened, things like that. We've leveraged off the work done at Harvard and MIT on their person course data set. So we actually have a table in our database for person course, and whenever we think of a new aggregated value that we want for each person in a course, we add that to that database, add the code into the ingester, and that gets aggregated automatically from then on for all courses, for all students, which is really nice. The API is a standard REST architecture. It's built on the Django REST framework. It includes a caching layer, because some of the visualizations and so forth that we build pull a lot of data. It's built around a course JSON file that we construct for each of our courses, which has where the URL for the course is, so it can pull things like images from the course info page. It knows the dates that the course is running, the date it opens, the date it closes, those sorts of things, so they can be used in calculations. And it's got modular authentication. We use LDAP for our authentication at UQ. The dashboard is one of the applications we've built on top of MoocCzar. It's Angular based, uses D3 for the visualizations. It's fully client-side, so it's all in the code that gets downloaded to your browser, and it exercises the API from your browser. So it's a little bit sluggish from this side of the world back to UQ. It gives us basic visualizations, and we can update it and add more visualizations as we go. That's a screenshot. Let's just quickly jump out and I'll show you it. So if you go to the UQX site at UQ and click on data, you'll see this infographic. 511,612 enrolments. That's nice. It's going up every day. And you can see for every one of our... So this is public, this infographic. So it gives the top level information about our courses, how many students enrolled, how many enrolments per day in the last week or so, how many certificates have been issued, whether the course is still running, that sort of thing. Is just there, publicly available. And that's actually worked nicely for us. We had a very irate journo ring up the other day. It sounded like they were going to write a really nasty article about us. Said, how many enrolments have you got in such and such a course? And we said, that information's all publicly available on our website at this URL. And then he wrote a really nice article. So I think being open really works. If you're a UQ staff member, you can log into the actual dashboard, which this is what it looks like. We have the various visualizations across the top here, enrolments, enrollment map, and so forth. And down the side we have all of the courses, and you can just pick them by year if you like. And so if I wanted to have a look at the current run of hypersonics and look at the enrolment. So this is a specialised engineering course. It's running in self-paced mode for a 12-month period at the moment. You can see the enrolments are relatively steady, but you can see a couple of blips where it pops up, and that's typically because someone's published a really nice article about the course on I Fucking Love Science or one of those websites. The academic who runs this course looks after it entirely by himself. 5,000, this is the second time it's run, so got more than that last time, but that's a lot of high-end rocket scientists. So he likes that. Actually, I should show you one of the other new visualizations we've put in is this one. Of course, I'm doing a demo here across the planet. This is the most complex visualization. It's going to take it a little while. We might come back and see if that completes. Actually, there's a picture of it here. So this is a new one we've done. So it basically serializes the course, all of the assets in the course, from, in the logical order. Module 1, first lesson, each asset through to module 2, all the way through to the end of the course, and then shows you the number of accesses of that resource per week of the course. So you can see here that the dark blue on this side is the first week of the course, and then which assets were accessed in the second week and which assets were accessed in the third and then fourth and fifth week. So you can see how many students are going back to the earlier weeks later in the course. It's quite a nice visualization. As I said, this infographic style report is made front end. Lots of people go and have a look at that to keep up with what's going on. So the takeaways are, we hope this platform can be useful to other people. We've just open sourced it. Anyone can download it and have a go with it. A couple of universities have had a bit of a play with it. It's designed to be modular, so you can expand it, you can adapt it to your own needs. It may or may not solve the problems you're after solving, but it works for us and we're continuing to put effort into it. Occasionally things break when edX change the format of the data, but not that often. Really I think it's part of the way we can have a community of people that are actually interested in what this data can tell us. So do with it what you will, and thanks to Andrew for developing a good portion of it. Questions? Yeah.
So are you creating any kind of generic reporting structure that people can use, an ad hoc tool to go against this data?
Yeah, so basically, are we creating an ad hoc structure that people can use? Yeah, so the idea is in the dashboard there's actually a page that lists all of the APIs, and so based on that, a researcher should be able to start exploring the data in a kind of ad hoc way, working out what's there and what they can pull out. And so the idea was that people could use this using programmatic exploration tools like IPython notebooks and R and so forth, just using API access.
Okay. But
Rather,
like for a Tableau to go against.
Yeah, so Tableau is something we're thinking that we might get a license for, because we want to use that for some on-campus analytics as well. So how we integrate that in with this is yet to be seen. Most of our stuff is all open source and running on Linux. I don't think Tableau runs on Linux, which is one issue.
How much transformation does your sort of ingester do and your APIs do? How close is the data model of what you have in your database and your APIs similar to what you bring in?
Yeah, so the data model, especially the SQL, how much do we manipulate the data and how close is the data model to what edX has? We stick pretty close to edX, so the SQL databases that we're building from the SQL dumps in the data set are probably identical to the SQL databases that they came from, almost. Except we do build a separate database for each course, rather than one database. The Mongo stuff is probably pretty similar. All the discussion board data is a Mongo database. It's all JSON. But what we do is we enhance the data by doing processing like IP address to country codes, doing various aggregations so that data is already pre-computed if someone needs to use it rather than wait for it to be computed, and so forth. Any more questions? Yes.
So you mentioned IP to country codes. Exactly what process are you using to decode that? Because we did some work with it and we noticed like a lot of places, very few places in the country in the US are concentrated. We started thinking maybe this is like people in a VPN or it's not actually where
Yeah, actually, that's one of the first things I noticed very early on is some countries, pretty well everyone's behind a single IP address. So at the moment, we have only been using it to the level of granularity of country. Although we have a use case now where we want to know within Australia which states the students are coming from, so we're adding that at the moment to that level, and we'll do whatever level the database that we have allows. But I think until we have a use case, we typically don't do stuff. So now we have a use case for state, we're putting state in, but that's the idea. It's driven by use cases. But once you have a use case for one course or one study, it's in the system and the data gets computed every time for every course from then on. So it's always there, which is nice. Thank you very much for your time.